Hello and welcome to my video. Today we are going to solve this problem. We want to determine the coefficients a, b, and c of the equation ax squared plus bx plus c equals 0 by choosing three distinct elements from this set. It has elements 0, 1, 2, 3, and 4. How many ways are there so that the equation above becomes question A quadratic equation, and question B, a quadratic equation having real roots? Alright, the first question is actually very easy. In order for this equation to be quadratic, we must have x squared term, hence a must be non-zero. So from this set, by excluding 0, there are total 4 choices for a. Once a is selected, b and c can be determined by picking two numbers orderly from the remaining 4 numbers, and of course they can have values of 0. Therefore, there are 4 permute 2 ways of doing that. Here this p means permutation. I am going to use this notation for permutation, but it is also denoted as these notations. And in case you don't know, the number of permutation can be calculated using this formula. Therefore, the number of cases where this becomes a quadratic equation is 4 times 4 permute 2, which is 4 times 3, which is 48. Now let's move on to the more interesting question. Now the condition is quadratic equation with real roots. For that, the discriminant of the quadratic equation must be non-negative. So we have the condition b squared minus 4ac being non-negative, which is b squared is equal to or greater than 4ac. Now we have to cleverly count the cases, and here let us change the value of c first, and let's begin with the smallest number. So the first case is when c equals 0, then the discriminant condition becomes b squared is equal to or greater than 0. This condition holds for all possible values of b, so b can be whatever number selected from the remaining 4. Moreover, we have the condition that a must not be 0, but we have already used 0 for c, so a also can be whatever number selected from the remaining 4. Therefore, the number of ways to choose a and b is the number of ordered arrangements of 2 distinct elements chosen from 4 elements, which is the number of permutation for P2. So there are 4 times 3, 12 ways to choose A and B in this case. Now let's move on to the second case, which is obviously C being non-zero. Here we also have the condition A must be non-zero. So from the discriminant condition, the right-hand side is greater than 4 times 1 times 1, which is 4. So we have B squared is greater than 4. Therefore, b must be 3 or 4. When b equals 3, the discriminant condition becomes 9 is equal to or greater than 4ac. Therefore, a and c must be either 1 and 2 or 2 and 1. Therefore, there are 2 ways. More precisely, there are 2 factorial ways, the number of arrangements of 2 different elements. So we have handled this case. Now let's move on to this case. When b equals 4, the discriminant condition becomes 16 is equal to or greater than 4ac. Therefore, 4 is equal to or greater than ac. Therefore, a and c must be 1 and 2 or 1 and 3. Therefore, there are 2 factorial ways here and 2 factorial ways here. So in total, we have 4 ways in this case. In total, the number of possible ways is 12 plus 2 plus 4 equals 18. And that's all for today's video. Thank you for watching, and I will see you in another video.